So I am from the Danish Technological Institute. We are a non-for-profit research and technology organization working sort of in between, making both services and also contract research for industrial use. I am coming from the Center for Nanoproduction and Microanalysis. We are around 25 specialists with quite a lot of facilities, both for characterization, but also for performing laboratories, both development and upscaling of different activities. I am, of course, coming from the printed electronics section and the group leader in there. A lot of the innovation or development work we are doing is through projects. Just to name a few, some of this, what I'm telling you, has been funded through the LEBED, which is an open innovation testbed project where DTI is coordinating. So you can actually, if you want more information, you can come to our booth later and I'll tell you all about it. So, to go back. So the activities where we're working in printed electronics are mainly are trying to sort of span the entire value chain, going from development and production of nanomaterials, of course formulating, printing, and then of course validation and testing of these, both the materials but also the components themselves. What I'm going to talk a little bit about in the next few minutes is more focused on the first two parts, the material development, production, and a little bit about the formulation. Just to tell you a little bit about what types of projects we do. So DTI, as a research and technology organization, we are sort of, assisting or helping, aiding other companies. So, and that could be a small startup that needs to have a proof of concept. And then we can also then take that proof of concept up to a prototyping where we do a more larger design, fabrication, and testing, sort of a system prototype. We can then help them even to, in some cases, go to a pilot production with some of the technologies we are having in-house. In terms of the nanomaterials facilities we have to our disposal, we are very good at making and building and designing and building reactors. We have several different types of reactors at our disposal. Some of them are small scale for rapid development. So just maybe a few liters, and some of them are going up to a larger scale, up to in the biggest case 80-liter batch reactors, or flow reactors that are going over a kilo per hour, depending on the material we're trying to make. Most of them, if not all of them, are PLC automated. So we go really in trying to automate these type of systems, because that's the only real way to bring down the production costs. And we also, of course, in most of our cases, have inline monitoring for quality control. Just some examples of some of the materials we've worked with in the many years. So many years ago, we started with the platinum alloys, and that was more for energy applications like fuel cells, etc., and catalysts. And from that, we sort of jumped over to other sort of printed electronics friendly materials like silver nanoparticles, copper nanoparticles, which I'll tell you about more in a minute. Copper and silver nanowires we have also been able to develop now. And some more exotic things like ferrite or magnetomaterials, barium titanate for hydroelectric materials, and even starting to play with how to improve the conductivity of like graphene by putting on or growing nanomaterials on top of it. This is the work we've been doing for the upscale of the production of nano copper that we have DTI. So basically, this is just a time lapse of the reactor itself, the important part of the reactor. So right now we have been able to validate up to 10 kilos per day, and that's mainly the main bottlenecks is the heating and the mixing of the different reagents that go into the process, and all the reagents are green and low-cost ingredients, of course. We are able to produce size down to a few tens of nanometers up to a few hundred nanometers. Right now, the production cost is around 300 euros per kilo, which is already on par, or actually a little bit better than silver, and with a material price of actually that way below 100 euros per kilo. So there's still room for improvement. Our goal is to go at least below 100 euros per kilo. So that is really then making these type of things much more cost effective than existing materials that you have today for conductive inks. just to show you, also we have done some work on the formulation. We have made an inkjet formulation some time ago, which is very nice. DGMI-based solvent, and with photonic sintering, we can go down to around 60 milliohms per square for, I think it's about a half a micron to a micrometer thick layer. So it's quite a good conductivity. We are currently working on the screen printable formulation, which isn't totally ready yet, but we are aiming for a very good 50 million per square per print. So this is happening. Hopefully in the next few months we'll have some more results on that. And with that, I'd like to say thank you very much, and come visit us in the booth. I think we're in exhibition
2.
part hell 2, correct? Yeah. Thank you very much.
Thanks,
Thanks,
Zach.
Gustav. All right.
You're welcome. See you.